Okay, so today I am going to talk about Einstein's energy mass relation, that is E is equal to mc square. So suppose there is a particle, and on that particle force F is acting, and say dx is the displacement, and say the direction of both F and dx will be the same, then small work done can be represented by F dot dx, as both are acting along the same direction. So that means it is simply F dx. Now this is stored now the force is nothing but it is the rate of change of momentum, and what is momentum? This P is the momentum, and relativistically it is represented by gamma mp. This is the relativistic gamma m naught v. Here what is gamma? Gamma is 1 minus b square upon c square under the root. That's what we are considering here. So therefore let us substitute the value of momentum. It is dp upon dt into dx, and let me rewrite down it. So it can calculate by integrating dek, and as velocity varies from 0 to b, so therefore we can write down it as a vdp, right? But as we know that momentum is like this gamma m naught b, where gamma is basically depending upon the velocity. So here m naught is what? M naught is the rest mass of the particle. So that means the mass of the particle is a constant, rest mass is and it is a constant quantity. That's what we have to keep in mind. It is the rest mass, means when the particle is at the rest, it is that mass. But otherwise mass is changing, because m can be written as m naught over 1 minus v square over c square. Because velocity is changing, so that means mass is also changing. It is the only case where the mass keep on changing. Otherwise in non-relativistic mechanics, mass will not change in most of the cases. So say the mass is changing, but because of this term which is sitting here. So let me do little more algebra here. It is 0 to v, it is v, it is d. Let me put the value of p from here. So it is gamma m naught v. We put it here, and it is this. See, m naught is a constant, so it can be taken outside the integral. So let me write down it like this: 0 to v, and v, it is gamma v. It's this one. And how this can be written as? If I try to look at it, say it is a drv. Sorry, d gamma v, not r. D gamma v. So it can be written as the d gamma into v plus gamma into dv. So means simply v d gamma plus gamma dB. It can be rewritten like this. And so if I put its value here, then it will become m naught 0 to b, it is v d gamma plus gamma dV. It is the value of this quantity, this particular quantity, which I am putting here. Now m naught, it is 0 to b, it is v square d gamma plus gamma dV. It can be written like this. To this one which we are getting here. Now let me try to look at this quantity, because this quantity comes out to be equal to this m naught d gamma c square. How? Let us try to prove that how this quantity is equal to this one. So as we know that gamma is equal to 1 minus b square over c square raised to power minus 1 by 2, or I can write it down like this, 1 over 1 minus b square over c square. Let me simplify it, because we need d gamma. So let us take square on both sides. So gamma square 1 over 1 minus v square upon c square, and it is gamma square, it is 1 minus v square over c square is equal to 1, which implies it can be written as gamma square, and it is c square minus v square over c square is equal to 1. So it is gamma square c square minus v square equal to c square. So it is gamma square c square minus gamma square v square is equal to c square. After doing simplification to this quantity, and say this is Ek, kinetic energy, it can be written like this. And and here it is, let me take the derivative on both sides. It is 2 gamma d gamma c square minus 2 gamma d gamma v square plus gamma square 2v dv is equal to 0. And because differential of the c square, here I have taken the differential on both sides, and the differential of c square is always 0, because c is a constant quantity. And if I try to look at it, this 2 gamma, and 2 gamma is also sitting here, and 2 gamma is also sitting here. So if 2 gamma can be taken outside, so what it will be, it is c square d gamma or d gamma c square, whatever you want to call. Means you can write down this quantity as also like this, m naught c square, because it is a constant, so it can be taken outside. So it is this one. So it is c square d gamma. Oh, sorry, this is this. So it is minus it is d gamma v square, or simply we can write down a text like this, and then v square d gamma plus minus, because minus plus will become minus. So it's gamma v dv is equal to 0. Since 2 gamma can never be equal to 0, so that means the second quantity must be equal to 0. So therefore I can write down it as the c square d gamma minus v square d gamma minus gamma v dv is equal to 0. What does it mean? This means that c square d gamma is equal to v square d gamma plus v gamma, right? So this is what we are getting here. So that means this particular quantity is equal to this one. That's what we have proved here. There are so many other ways to solve this particular equation. So different books follow different methods. So here we got this quantity here, and m naught c square t gamma. So yeah, now the question arises that m naught c squared is a d gamma. So what is the value of this d gamma? That's what we need to find out, because we do not know that what is d gamma now. Sorry, it's ek, and it is it is 0 to v. So let me again recall. Yeah, its gamma is equal to 1 minus v square upon c square raised to power minus 1 by 2. Sorry, 1 by 2. So it can be written as, not minus, but it's plus. Yeah, it can be written as 1 minus v square over c square raised to power minus 1 by 2. Let us try to find out d gamma. D gamma can be written as, minus 1 by 2, 1 minus v square over c square raised to power minus 1 by 2 minus 1, because here I have used the formula that x raised to power n, its differential can be written as nx raised to power n minus 1. But this is not simply simple quantity. So that means we have again to take the differential of this quantity. So its differential will be 0. So it is minus 1 over c square. Yeah, it is minus 1 over c square. It is 2v dv. That's what we can write it down. So this is its complete differential. This will cancel out with it. This minus will, both minus will become plus. So d gamma can be written like this. So it is 1 minus v square over c square raised to power minus 3 by 2. It is 1 over c square. It is v dv. Let us put its value here. So if I put its value here, so what it will become? It will become m naught c square 0 to v. So it is 1 minus v square over c square raised to power minus 3 by 2. It is 1 upon c square, and it is v dv, and say this c square will cancel out with this c square. So it is m naught integral 0 to v. So it can be written as, by simply writing it as, bringing this in the denominator, because the power is minus 3 by 2. So it is 1 minus v square over c square raised to power 3 by 2. That's what we are getting, and it is dv. This is the quantity. Now we have to simplify this particular quantity. So for this, let us proceed as follows. So to simplify this, let us do little more algebra. Yeah. So let us assume that because we are interested to find out this quantity. So first of all, let me talk about it. So it is v over 1 minus v square over c square raised to into dv, and let us assume that y is equal to 1 minus v square over c square. So 3 by 2 will be there. So what it will become? Dy is equal to minus 1 over c square to v dv. So what v dv can be written as? V dv can be written as c square dy over 2, with the minus sign will be sitting here. So if I put this value here, so what it will become? It will become so it is 1 over y raised to power 3 by 2, and it is minus c square dy by 2, and its integral. This is it. So it is minus c square by 2 can be taken outside, so it is y raised to power 3 by 2 into dy. So integral of x raised to power n is equal to x raised to power n plus 1 over n plus 1. This is the formula which we are applying here. So it is minus c square by 2 y raised to power minus 3 by 2 plus 1 and minus 3 by 2 plus 1. That's what we are getting. Minus c square by 2, it is y raised to power minus 1 by 2 and minus 1 by 2. So it can be written as minus c square by 2 and 2 by 1, with the negative sign is sitting here. It is y raised to power minus 1 by 2. So this will cancel out with it. Minus minus will become plus. So it is y raised to power minus 1 by 2 into c square. This is the quantity which we are getting. Right. And let me do one more thing. Because what is y? So it is basically c square, and it is 1 minus v square over c square raised to power minus 1 by 2. This is the value, and we have to put here limits because v varies from 0 to v. This is the limit which we are getting. So that means what should I do? So that means this is ek, and ek is equal to this, and its value is evaluated equivalent to this one. So if I put its value here, then this ek will become m naught c square 1 minus v square over c square minus 1 by 2, and here it is 0 to v. It is the limit of the velocity. So c square is a constant, so it can be taken outside m naught c square. So here we can use the value of upper limit. So it is 1 minus v square over c square raised to power 1 by 2. It is upper limit, and 1 minus 0 square over c square, it corresponds to lower limit. So what we are getting here, it is m naught c square 1 minus v square over c square raised to power minus 1 by 2, then minus 1. That's what we are getting here. Right, so that's what we are getting here. So let me write it down. Oh, sorry. So now ek, it can be written like this. It's a kinetic energy. It is equal to m naught c square 1 over 1 minus v square over c square under the root minus 1. So it is m naught c square over 1 minus v square over c square under the root minus m naught c square. So what is the value of ek which we are getting here? So ek is equal to m naught c square over 1 minus v square over c square under the root minus m naught c square. And as we know that m is equal to m naught over 1 minus v square over c square under the root. So if I put this value here, so it is mc square minus m naught c square is the kinetic energy. So it is mc square. So here mc square comes out to be m naught or ek plus m naught c square, right? So yeah, so what is mc square? It is the total energy. And what is ek? It is the relativistic kinetic energy. Kinetic energy plus m naught c square means it is the rest mass energy. It is the rest energy. So this is the relationship. So from here we can calculate the total energy, that is E. It can be written as mc square, and which is further equal to ek minus ek plus m naught c square. So this is the expression for the total energy of the system. And there is one more interesting thing which we have to keep in mind, that is as relativistic kinetic energy, or from relativistic kinetic energy we can derive non-relativistic kinetic energy. Means relativistic, non-relativistic kinetic energy is a special case. So let us try to understand that. Relativistic kinetic energy is given like this. It is mc square minus m naught c square. So it is m naught 1 minus v square over c square under the root c square minus m naught c square, and let us solve this. So it is m naught c square, it is 1 minus v square over c square raised to power minus 1 by 2 minus m naught c square. As we know that v is very much less than c, so v square over c square again very much less than 1. That means we can apply here the binomial approximation, that is 1 plus x raised to power n is equal to 1 plus nx. So if apply this part here to this one, so it can be written as m naught c square 1 minus v square over 1 minus 1 by 2 into v square over c square, it is equal to this one minus m naught c square. This quantity will remain as it is. So it is m naught c square 1 plus v square over 2c square plus m naught c square. So it is m naught c square plus m naught c square v square over 2c square plus m naught c square. This will cancel out with, oh, minus is there, sorry, because of this, yeah, this minus will be there, so this will cancel out with it. So it is m naught c square, and this c square will also cancel out with m naught v square over 2. So this is the actual kinetic energy of the system when it is in the non-relativistic, so which can be derived using this particular relationship, right? So that's all for this, and I will talk about the physical significance all this in the class. So that's all for this lecture.